All right, this is the second lesson in the week of April 27th through May 1st, and this is called molarity. And what we will be doing in here is looking at one way that we can measure the composition of a solution. And what we want to do when we measure the composition of a solution is we want to compare the parts of the solute to the parts of the solvent, or sometimes the parts of the solute to the parts of the entire solution. In other words, we want to compare how much of each do we have, but it may be that it's more convenient to measure one part versus the whole rather than the two parts versus each other. There's actually so many ways to measure what we would call solubility. How much is as well, that's actually not right, to measure the concentration of the solution. There's a part that if you have your dad or mom or whoever's the one who gets this stuff in your house, there's something called a water quality report that you get every year from your water people, and they'll talk about that there's this much of this chemical, and they'll do it in parts per million or parts per billion or parts per trillion. In that case, they take a solution and they break it down. They figure out how many parts are there and how many parts per million are this contaminant. There's also something called a percent, a mass percent, where we do something very similar. There's another unit that we use specifically for organic compounds, but what we're going to work with, our measure of concentration will be called molarity. Molarity. Molarity is when we measure the moles of solute to the liters of solution. And that is molarity. The symbol for molarity is a capital M. And there is an equation, and that is that capital M is moles divided by liters. But again, the moles is the moles of the solute, and the liters is the liter of solution. So what we're going to do is we're actually going to count the water molecules. Put that up a little bit. We're going to count not the water molecules. Remember, in chemistry, we count with moles. We're going to count the number of solute particles, and then we're going to say how many liters is that in. Now, we're measuring the entire solution, not just the solvent, and that would make a difference in the way we mix up solutions. If you were in class, we would actually mix up some solutions so that you would know how to mix this. It'll be a little harder without you being able to be there in person, but we'll do the best that we can. This is actually a fairly easy section because what will happen is this can be rewritten one of three ways. We have molarity as moles divided by liter. And by the way, when we talk about, well, we'll get to that. If I want to know how many moles of something I have, if I know the molarity of that solution and the liters, I can just multiply those two together and it'll tell me how many moles. Or if I want to know how many liters of something and I know the molarity, I can then figure out how many moles, and I know the number of moles, I would do this. So you might say, well, when would you do that? Well, let's say I'm doing a problem and I need X number of moles and I have this molar solution. I can pour it out. I do that all the time when I mix up chemicals for labs, which we used to have when we met together. So this is your formula for molarity. So let's say that we had, 500 milliliters of solution, and we have 25 grams of sodium chloride. And I'm going to have the 25 grams of sodium chloride in the 500 milliliters solution. The question will be, what is the concentration, or what is the molarity? All right, well, we have actually two changes we have to make. 500 milliliters has to change to liters. This will happen a lot in your homework. Most of the things we work with are milliliters, not liters. So remember, the way we go from milliliters to liters is we move the decimal place 3 places. So 500 milliliters is 0.5 liters. 25 grams is fine, but I need to change that into moles. So 25 grams of sodium chloride, 1 mole of sodium chloride. Been a long time since we've done this, but sodium is 23 and 35.5, 58.5 grams of sodium chloride, and that would give us 25 divided by 58.5. And that would be 0.427, 0.43 moles of sodium chloride. So if we want to find out what the molarity is 0.43 moles divided by 0.5 liters, and this will end up being 0.86. And we put a capital M and then put NaCl solution. And the way this will be said is we will say this is a 0.86 molar NaCl solution. So it's not particularly hard to do that. And you'll have problems that would be like that. Let's do a second one. Let me erase this. Let's say that we had 25 milliliters of solution, and we have in that and 2.74 grams of, oh, let's put sugar in there. Well, let's not do sugar. Let's do vinegar, CH3COOH. What is the molarity? Well, molarity is always moles divided by liters. We've got 25 milliliters, that would be 0.025 liters, 2.74 grams of vinegar, 1 mole of vinegar, and I've got 2, that's 24 and 32. Actually, I meant to do it this way. It's 28, 56, 60. 60 grams of CH3COOH. And so that's going to be 2.74 divided by 60, and that is 0.046 moles. And then we would divide that 0.025, and we would get 1.83 molar solution of CH3COOH. All right, so that's pretty straightforward. Let me take you through, this is going to be a little shorter video, let me take you through a couple other problems that will pop up. They could ask something like this. This would be real common. You want 15 grams of, oh, let's say, MgSO4, that's called Epsom salt. You have a 5.2 molar solution of magnesium sulfate. How many milliliters of solution should you pour out, or should you use? Okay, so let me just explain the problem in case you don't see it. I've got this bottle here, or container, and this has 5.2 molar solution. That means that I have water plus magnesium sulfate. I want 15 grams of magnesium sulfate. How much of this should I pour out to make that happen? How many grams of that should I pour out? So I'm going to pour some of this out into a smaller cup, but I want to make sure there's 15 grams of magnesium sulfate. Well, if you think about this problem, what I'm actually after is this right here. I'm after liters. So it says milliliters, but it's liters. I know what molarity is. That's 5.2. What I need to do is, again, change 15 grams of magnesium sulfite into moles. So 15 grams magnesium sulfate, 1 mole of magnesium sulfate. Magnesium is 24.5, sulfur is 32, oxygen is 4 times 16, so 24.5, 32, and 64, 120.5. And this then will be 15 divided by 120.5, and I have 0.124 moles. So in essence, what's really happened is they told me they wanted 15 grams, but we don't count in grams, so that's actually 0.124 moles. And now we should be able to figure out how many liters we want. This equation here. Liters is 1.24 moles. 0.124 moles divided by 5.2 molar, and 0.124 divided by 5.2, and this is 0.024. And then be careful, this is 0.024 liters. What did they ask for? They asked for milliliters. So this would be, move it over 3 places, 24 milliliters. And again, this is something that I use a lot when I am preparing solutions for you guys. I figure out how much I want and work backwards to it. Let's do one other problem. And again, most of the time we don't start with moles, we start or end with moles. That's an in-between. We'll go to grams instead. So we could have a problem like this one. You have 50 milliliters of a 6.0 molar HCl solution. How many moles, well no, let's not do moles, how many grams of HCl do you have? Okay, now once again, we are have an in-between step. I will just tell you right now, when you see grams, think moles. I can't get to grams, but I can get to moles, and I can get to it right here. So the number of moles is 6.0 molar times 0.05 liters, and this will end up being 0.3. So the number of moles is 0.3, and therefore I have 0.3 moles of HCl, but that's not what I want. I want grams. So 1 mole of HCl is 36.5 grams of HCl, and we would have our answer. 0.3 times 36.5, and this would be 10.95, or roughly 11 grams of HCl is what you would end up having. So that is molarity. It's relatively simple. One last thing, though, I want to mention. I think there's a question in your book about this. Because we are making a solution, counting moles of solute to liters of solution, there's actually a proper way to mix up a molar solution. And the way you mix it up is this. Let's say we wanted to mix this up. Let's say instead of this, I said I want 50 milliliters of 6 molar HCl. How would I mix that up? Well, the mixing instructions would be this. Pour less than 50 milliliters of, of water into a beaker. Add 11 grams of HCl, and then stir until dissolved, and then add enough water to get to 50 milliliters. So let me explain why. Most of you probably don't need me to explain why, but let me explain why anyways. I've got a beaker, and let's say that I filled it right up to 50 milliliters. And then I took a big bunch of HCl, and by the way, it doesn't come like that, but for the purposes, and I drop it in there. What's going to happen to that 50 milliliters? Well, as soon as I add a little bit of something to here, this water level is going to go up, and let's say it goes up 2. I have 52 milliliters. That may not be too far off, but it's not 50 milliliters either. So rather, what we will do is we'll say put in 40 milliliters of water. We'll put in the HCl. This will raise up, say 2, so now we're at 42 milliliters. Once this is all dissolved in here, then we will add the rest of our water to get right up to 50 milliliters. So in class, if we were doing this, I would have instructions for you, or where you would actually write up the instructions. I would actually give you chemicals, and I'd say, I want you to mix up this molarity of this, so many milliliters of this molar solution, and explain to me how you're doing it. So there's a question in your book on it. What we're going to do in this section is